Hi, my name is Mackenzie Ponsell, and this is my Physics 2211, Lab 5, Motion of a Falling Slinky. In this lab, we'll create a computational model of a falling slinky. We use Python to model the slinky's motion. We will iteratively calculate the position of the bottom of the slinky. We will compare the model to the experimental values determined by the motion tracking software Tracker. The question for this lab is, how does the slinky move? Does the bottom of the slinky fall, pulling the top of the slinky downwards? Does the top of the slinky fall, meeting the bottom, and then they fall together? Does the top and the bottom fall at the same time? Or does the bottom of the slinky move upward to meet the top of the slinky, and then they fall together? We've identified the system as the Earth and the slinky. We will use Newton's second law to calculate the velocity and the position of the slinky as it falls. Gravitational force and drag force are the two interactions that are acting on the slinky as it falls. Gravitational force works in the negative y direction, as the drag force works in the positive y direction. You can see on the right how those are inputted into the code. This is where we analyze the video of the slinky falling in Tracker. The origin of our graph, 0, 0, is determined by the bottom of the slinky. You can see that when the video is played, the bottom of the slinky stays at the origin as the top of the slinky falls. This is the case up until the 6th second, when the top of the slinky meets the bottom of the slinky. When this happens, the bottom and the top of the slinky fall as one single mass until reaching the bottom with a constant acceleration. The graph shown in the top right is a plot of the y position versus time as the slinky falls. This is the code for the computational model we created using GlowScript. We start with some initializations, such as the slinky's mass, initial position, and initial velocity. Both the initial position and velocity vectors are 0, 0, as the slinky was dropped from rest, and the bottom of the slinky was placed at the origin of our graph, 0, 0. Interactions include gravity and the drag coefficient, which is 2.6, and we determined this experimentally. In the first while loop, this is the time up until the bottom of the slinky met the top of the slinky. During this time, the weight force and the force of tension on the slinky were the exact same, and this is why the bottom of the slinky stayed at rest until the top of the slinky approached it. In the second while loop, this is the entire time that the slinky is falling. We have the drag force and the weight force of the entire slinky. We use momentum principle to calculate the velocity and position as the slinky falls. We will now compare the experimental versus modeled motion. If you look on the right at the top, this is the graph determined by our GlowScript code. You can see that up until the 6th second, the y position of the bottom of the slinky remained at 0, 0, the origin. Once it passed the 6th second, this is when the top of the slinky met the bottom of the slinky, and they fell as one single mass continuously. Below this is the graph that Tracker produced. It's very similar in the fact that the y position of the bottom of the slinky was 0 up until about the 6th second, and then after that, they began to fall as 1. However, if we compare the GlowScript graph to the Tracker graph, there is a large amount of deviation. This can include, but not limited to, not including all forces that are acting upon the slinky as it's falling, such as possible tension still residing within the top and the bottom of the slinky, assumptions that were made, such as the drag coefficient, or using the point mass versus the center of mass representation of our system. We described the slinky's motion as the bottom of the slinky stayed at rest as the slinky was dropped from static equilibrium. This is because tension and gravitational forces canceled up until the slinky met top and bottom. The bottom and the top of the slinky fell as one mass when they met together.